Have you ever wondered how a wild new idea in a physicist's head actually becomes a scientific fact you read about in a textbook? It's a pretty incredible journey, you know? It's filled with logic, a very specific kind of language, and honestly, a surprising amount of hope. So let's trace that path, right from the very beginning.
So, how does it really happen? We tend to think of science as this super clean, totally objective process, but the road from a brand new concept to a truth that everyone agrees on, well, it's a lot more complicated and frankly, a lot more human than you might imagine. Let's follow a physicist as they try to get their idea out into the world.
Everything starts right here. Just a single physicist wrestling with a new idea. This is that first step, conceptualization. It's that moment of trying to see the universe in a totally new way, trying to make sense of something that our current theories just can't seem to get right.
Okay, so this is the basic roadmap for our physicist. It all kicks off with that creative spark. You conceptualize the idea. But an idea, well, it's not enough on its own. It has to be described with absolute precision. Then, it has to be explained in a way that actually connects to reality. And after all that work, the final step is almost a leap of faith, hoping that everyone else is ready to believe it.
So now we're going to move from that fuzzy world of ideas into something much more solid. To make a concept real, to actually test it and share it with other people, our physicist needs a language that leaves zero room for misinterpretation.
And that language, it's mathematics. A concept, no matter how brilliant it is really just a thought floating around until it's pinned down with equations and formulas. Math is the tool they use to build a working model of the idea, giving it a solid structure that other scientists can actually analyze and poke at.
But, and this is a huge but, having that mathematical model isn't the end of the story. See, a description is one thing, but an explanation is something else entirely. To really explain something, that beautiful set of equations has to connect to the real world, to actual measurements coming from a real device. This is the moment where abstract theory gets a reality check.
So let's say our physicist has the math, and they've connected it to real-world measurements. You'd think the job is done, right? Not even close. Now comes a challenge that is deeply, deeply human, making other people actually understand the explanation.
And this quote just hits the nail on the head. Science isn't done in a vacuum. To get an idea understood, a physicist has to do what are called sociological things. That means publishing papers, giving talks, arguing with their colleagues. The art of convincing and communicating is every bit as important as the research itself.
So you can think of understanding as a two-part mission. First, the physicist has to be absolutely 100% clear on it themselves. But then comes the real mountain to climb, transferring that exact same clarity into the minds of others. If you can't do that second part, even the most amazing discovery is just going to fade away. It's a brilliant idea that goes absolutely nowhere.
All right, let's move on to the final stage. And this one might just be the toughest. After all that thinking, all that math, all that explaining, the physicist arrives at a point where the outcome is completely out of their hands.
This is it. This is the dream. The ultimate hope is that the whole community looks at the work and says, "Yep, we believe this," not as some act of blind faith, but as a collective agreement that this new explanation is the best, most probable description of reality we have at this very moment.
But wait a minute, here's a huge twist in the story. After this whole long, rigorous process, are we actually looking at reality itself? Or are we just looking at something our own minds created? This question, it cuts right to the very core of what science is.
And here's the profound challenge. The way we do science depends on making distinctions. We measure things like temperature, position, mass. But what if reality itself doesn't make those same clean-cut distinctions? It's very possible that our scientific methods are forcing a structure onto the universe that isn't naturally there. We might be looking at an incredibly detailed map, but not the actual territory.
And that brings us right back to the human side of this whole journey. Because even with the best data and the most elegant math in the world, acceptance is never, ever guaranteed. I mean, history is just littered with amazing scientific ideas that weren't understood or weren't believed for years, sometimes even decades. This journey is filled with uncertainty right up to the very end.
So this leaves us with one last big question to chew on. When we accept a new scientific theory, what is it we're actually believing in? Are we believing in a perfect photograph of reality? Or are we believing in the best, most useful, and most elegant human-made explanation that we've managed to come up with?
So far.